Hi, welcome to the video for our next lesson. This continues our study of probability, and today we're just going to look at several different questions that have to do with probability in the context of games. So here is a picture that shows the sample space for rolling 2 dice. So there are 36 different possibilities, and the first question about this asks, what are 3 possible number combinations that make a total of 7? So just in general, if you think about the numbers on a die, or 1 through 6, you could have a 1 with a 6, you could have a 2 with a 5, or you could have a 3 with a 4. Now, in rolling the dice, each of those actually yields 2 different outcomes. So 1 and a 6 happens in 2 different ways, and sometimes students are confused about why we would count these both. If you think of the dice as being 2 different colors, like say that the first die was red and the second die was green, then a red 6 and a green 1 is different from a 1 on the red and a 6 on the green. I hope I said that right. I was trying to say it backwards. So those are 2 different outcomes, right? Think of the 2 dice as like having names to them, right? So dice A 6, dice B 1 is different than dice A 1, dice B 6. Okay. Here are the 2 and 5 combination. And then there are 2 different ways to roll a 3 with a 4. And so when it says, what is the probability of rolling a 7, you can see that right here we have 6 different ways out of 36, or 1 out of 6, or about 17% if you round that. So something that's interesting about this dice array is that you do have common sums or totals along the diagonal. So the way that it's organized, you can see that all of the 7s were along this diagonal. All of these rolls total 8. All of these rolls total 9. All of these are rolling a 10 as a total. This is 11, and this is 12, and I could go back down on the other side as well, right? This is 6 and so on, okay? Going down. So it's interesting to notice that, and because of that realization, I can see that the most common total is going to be rolling a 7, and that the least common totals are these at the edges, right? Rolling a total of 2 or a total of 12. Both of those are equally likely or unlikely depending on your perspective, right? So if we were to make a graph of this, our graph would have like a small probability both for 2 and for 12. And then there's one more way in each case of rolling a 3 or an 11. And my graph would keep going and have like a hill shape to it, okay? That's something that's called a probability distribution, okay? I didn't fill it all in, okay? But I just thought it would be an interesting thing to notice, right? That 7 has 6 outcomes, right? And nothing else has as many outcomes as the 7. So the 7 is the most likely roll. All right, so what is the probability of rolling snake eyes or double ones? Well, we just were talking about that. This is the roll that is called snake eyes or double ones. There's only one way to do that out of 36. And this next question, think. If a player happens to get snake eyes 20 times in a row, they roll, they get double ones. They roll again, they get double ones. They roll again, they get double ones. That happens 20 times. What is the probability that they get snake eyes on the 21st roll? I hope you just said in your mind, whoops, I hope you just said in your mind, Mrs. Limpy, you're still on the highlighter. I hope you just said in your mind, 1 out of 36. The fact of streakiness doesn't change the individual rolls probabilities. It still is the same mathematical probability. All right, this now is talking about a game called roulette. Maybe you've seen this shown in movies before. The roulette wheel is the one that has like a big thing that spins. It's a casino game, and it has a big wheel in the middle, and there's a ball that kind of bounces around the wheel as it spins, and then the ball lands somewhere. And people will place bets on where the ball is going to land. So a roulette wheel has 38 slots. There are 36 numbers that are 1 through 36. And then there are 2 slots that are labeled with zeros. There's a single 0 and there's a double 0. The single 0 and the double 0 are both green. And the other numbers, the ones that were the 1 through 36, half of them are black and half of them are red, okay? So 1 through 36, half black, half red, and then the ones that are green. All right, so the first question is, what is the probability that a ball lands red? Well, there are 38 slots, so that's my sample space, right? There's 1 through 36, and then 0 and double 0, so that's 38 in all. And then when it said half are black and half are red, that was pertaining to the 1 through 36. So 36 divided by 2 is 18. And so we want to say that there are 18 reds out of the 38 slots. So that would be my answer there. If I had it as a decimal, it would be about 0.474. Okay, the next question asked, what is the probability of landing on an odd number? Well, 0 and double 0 are not considered to be odd numbers. So again, half of my 1 through 36 are going to be odd numbers. So this is going to be the same answer as the previous question. Numerically, I mean, it's a different question, but it has the same number as its answer. The next question asked, what is the probability that the ball lands on the 32? Okay, well, there's only one slot that's labeled 32 out of all of the different outcomes, which are 38. Okay, and this next question I think is very interesting. So it says the house pays 35 to 1. So that means if you were to bet one chip, you'd get 35 chips by placing your bet on the number 32. And explain what this means and why the house is considered unbeatable. Okay, well, we just said that the probability of getting the ball to land on the 32 was 1 out of 38. So that means that my odds are 37 to 1. But the house is paying 35 to 1. So why isn't it the same? Well, it's the same because the house is taking a cut. The casino is paying less than the true odds. These are the true odds. And the house is keeping 2 extra chips for every 38 chips wagered. Okay, so I'm going to write that out. House keeps 2 extra chips or 2 extra dollars or whatever unit you want to think of. Okay, keeps 2 extra chips for every 38 chips bet. So that is a cut of like 5.26%. So is that a ton? No, it's not a ton, but the house is involved in every single transaction. It's you versus the house, you versus the house. You know, gambler A versus the house, gambler B versus the house, gambler C versus the house. And so by doing that, that's that little cut on every play. That's why casinos are fancy. Never forget. Okay. All right. Question 3 is about dice again, but it's about different kinds of dice. So if you've ever played like a role-playing game, like Dungeons and Dragons or something like that, you might have seen that there can be dice that are not just cubes. So this would be your 4-sided die, which is a triangle on every face. So it's a triangular pyramid. And usually these are labeled so that you actually are rolling the number that's on the bottom. And so they might have like at the point of the pyramid, they might have like little numbers that say what is on the bottom or something like that. And so you have 2 of these dice. One of them is red, one of them is green. Little triangular pyramid dice. And because they have 4 sides, you only have 4 numbers, not 1 through 6, but 1 through 4. And they want us to answer these questions. Well, what I would suggest doing is trying to make something that's kind of like what we saw back here, right? So give yourself a picture to work from. And so my picture, so to speak, or my chart, is to be, okay, here's my red die. I can get 1 through 4. Here's my green die. I could get 1 through 4. And I want to write down the rolls that I get in each case. So this would be a 1 with a 1, a 1 with a 2, a 1 with a 3, a 1 with a 4, and so on. I'm getting a little sloppy here and not writing all those commas. I hope that's okay. Tidy it up a bit. Okay, so there's my sample space. right? I'm giving all the different possibilities. So how many possibilities are there? There's 16 because there's 4 in each way, right? If you look at the black part of this chart, there are 16 entries. And then a sum of 4 would be these outcomes along that diagonal. So that would give me an answer of 3 out of 16. And then the other question said, what is the probability that you get the same 2 numbers on each die? In other words, what is the probability of rolling doubles? I could have a 1 and a 1, a 2 and a 2, a 3 and a 3, or a 4 and a 4. And those are the only ways of rolling doubles. So 4 out of 16. Obviously, you can reduce this or write it as a percent, whatever you want. Doesn't matter. Okay? Right, now this last question has to do with the deck of cards. And so I was thinking after making the last video that maybe it would help to have a picture of the deck of cards. So I have that for you in this video. And then if you are able to print out the sheet, you can print out the sheet. If you're not able to print it out, then maybe you can take some notes down on this. But this shows diamonds is the name of this row, right? All of those have like a little red diamond shape to it. These are the clubs, these are the hearts, and these are the spades. Okay, and so then it shows you the pictures that are on each of those cards. And this question says, okay, we take these 52 cards that are shown in the picture and we shuffle them and then we pull out one card. And the first question says, what is the probability that the card is black or a king? So here's the thing. This is actually an interesting question in that I can see that all of these cards are black, right? So that's half the deck, or 26 out of the 52 cards, okay? But in this, I've already counted the kings. Well, some of them anyway, right? So over here, those are my kings, and there's 4 out of 52 cards that are kings, but you see, these cards got counted twice. So one way to adjust for that would be to subtract those cards that I got counted twice. Okay, that's not the only way, but it is a way. And so my final answer should be 28 out of 52. You could convince yourself that that's correct by going through and counting. 1, 2, 3, 4, 5, 6, right? Go through and count all of these cards and all of these cards and then this card and then this card. Right? Those are the cards that are either black or a king. Are some of the cards both black and a king? Yes. But when we say or in probability, we mean this, like we mean black or king or both. That's what the statement means in probability life. Okay, the last one says find the probability that you have, let me erase all this, sorry. Find the probability that you have a face card or a red when you pull a card. Well, all of these are face cards. And then the red would be all of this and then all of this. And again, there's some overlap there. So let's think about this and be very careful. Okay, so the face cards, how many of those were there? There were 12. And then remember how I mentioned in the other video how or means adding. Okay, and then I'm going to add on to that the reds that I have. 26 of the 52 cards are red. But then I'm going to subtract the ones that got counted twice, which would be the face cards that are also red. So that should leave me with 32 out of 52. If you did this differently, but you still got this answer, great. I don't mind. It's fine. However you get there is great. The right answer is what matters in this context. Okay? So good if I wrote anything there. I did not. So the problem set that goes with this is problem set 4.2. So please do that. And please make sure that you've checked your answers from the problem set 4.1. Thanks.